Hey everyone, welcome back to The Explainer. I am so thrilled to have you here today because we are tackling a topic that feels like bleeding edge computer science, but honestly, it's pure rigorous architecture. We are looking at the complete life cycle of building an artificial intelligence model from scratch. I want you to think about this not just as a coding tutorial, but as a masterclass in construction. Building an AI model is exactly like constructing a massive, state-of-the-art skyscraper. You don't just start throwing steel beams into the sky and hope they stick, right? You need a blueprint, you need a rock-solid foundation, and you need really rigorous safety inspections. So today, we're going to architect some intelligence. Okay, let's dive right into this structural blueprint. We'll be covering defining the problem, data collection and preprocessing, selecting the right model, training and evaluation, and finally, optimization and deployment. These 5 steps right here, that is our sequential journey today. Because just like in real-world construction, you absolutely cannot lay bricks or pour concrete or write algorithms, in our case, without having this master blueprint in hand. Try to skip a step or do them out of order, and it's a guaranteed recipe for structural collapse. Every single phase heavily relies on the success of the one right before it.
All right, phase 1. 1. Defining the problem. Let's pour the foundation.
Before we write literally a single line of code, we have got to step back and ask, what are we actually trying to solve? It sounds incredibly basic, but you would be shocked how often this is the most skipped step in amateur projects. AI is fundamentally a tool for problem solving. This is exactly where we have to establish our key performance indicators, our KPIs, and define our exact objective functions. Are we optimizing to minimize false positives in a medical scan, or are we maximizing click-through rates for some enterprise platform? Your answer dictates every single engineering decision that follows. If you don't know your precise metrics for success, you have no idea what architecture to build. Moving right along to phase 2. 2. Data collection and pre-processing. Time to gather our materials. Here is the harsh reality. Raw data is inherently messy. We're talking riddled with null values, crazy outliers, and just tons of extreme noise. And you cannot build a skyscraper with rusted steel. So pre-processing is where we roll up our sleeves and get to work on feature engineering, normalizing distributions, and handling those really annoying class imbalances. Because that golden axiom in computer science, garbage in, garbage out, it strictly holds here. We have to ensure the absolute mathematical integrity of our materials, or our model is simply going to learn to replicate the noise. Next up, phase 3. Selecting the right model. Let's look at the frameworks. Let's break down the tech stack. Python is pretty much our undisputed lingua franca here, giving us this vast ecosystem of libraries that we absolutely need. For the actual heavy lifting, TensorFlow remains the industry workhorse. It's highly scalable and explicitly built for massive production pipelines. PyTorch, on the other hand, is definitely the researcher's favorite. It offers these dynamic computation graphs that are just perfect for rapid prototyping and quick iteration. Ultimately, your choice here depends entirely on your specific deployment goals and your infrastructure. But hey, the tools only build what the algorithm dictates. Selecting the right machine learning algorithm is basically like choosing the specific physics and load-bearing designs for a skyscraper. If you're working with really complex tabular data, you might want to implement an XGBoost framework. Or if you're building a computer vision application, you're definitely going to need the deep spatial hierarchies of convolutional neural networks, or CNNs. The algorithm is the core mathematical framework that dictates exactly how our AI processes the information we feed into it. All right, phase 4. 4. Training and evaluation. Active construction begins. Now, we definitely do not just dump all of our pristine data into the model at once. No way. We implement a strict data split, typically an 80-20 rule. We train the model on that 80%, but we hold back that 20% to use as a completely unseen testing ground. This is absolutely crucial for rigorously detecting overfitting and preventing data leakage. It guarantees our model is actually generalizing broad patterns and not just lazily memorizing the training data. Basically, it keeps the AI mathematically honest. And that honesty check happens right here in the iterative loop. You feed in the training data, you calculate the loss against your objective function, and then you update the weights via backpropagation. Wash, rinse, repeat. Thousands, sometimes millions of times across countless epochs. This continuous evaluation using validation sets is what prevents major structural flaws in the model's logic long before the system ever goes live in production. Finally, we hit phase 5. 5. Optimization and deployment, the grand opening. Before we can actually open the doors, we have to undergo optimization.
Now, in AI deployment terms, this does not just mean tweaking the training. We are talking about model compression. We implement intense techniques like quantization, pruning, or Onyx runtime conversions. We are actively reducing latency and compute costs so that when this model faces real-world API calls, it runs incredibly fast and scales beautifully without draining massive amounts of server power.
So after optimizing for latency, we execute system integration. An AI model does not live in a vacuum. It requires a really robust MLOps pipeline to interface seamlessly with existing APIs, databases, and user front ends. And finally, deployment. We go live. The model leaves the totally sterile, safe environment of the lab and enters the chaotic, unpredictable real world. And if there is one absolute truth you take away from this entire architecture, it's this. Deployment isn't the finish line, it is the starting line for real-world learning. The second your model goes live, it is immediately subjected to changing environments. We call this model drift or data drift. Data shifts naturally, user behaviors evolve, and your baseline metrics will fluctuate. Continuous monitoring and automated CI/CD retraining pipelines are absolutely mandatory to prevent structural decay over time. Which leaves us with this crucial final thought. You've built your skyscraper. You've successfully architected intelligence from scratch, going from raw, messy data all the way to a live, highly optimized deployment. But the world around it is going to keep spinning and shifting. Once deployed, how will your AI adapt to a world that never stops changing? Because understanding how to build it, that's really just the beginning. Understanding how to evolve it is where true mastery lies. Thank you so much for joining me on this structural journey today. Keep asking great questions, and I will see you in the next